Which brings us to the horizontal deflection circuit. Turn to page, something or other here. Wait a minute. I don't know what page we want to turn to. Uh, 53. In fact, what I want you to see really is the schematic diagram on page 54, really, is what I want you to see. And this is the horizontal circuit in the monitor. The horizontal circuit can be the easiest of all circuits to work on in the monitor. Absolutely the easiest, where you can diagnose most horizontal problems in 200 milliseconds, very simply. Or it can be the biggest pain in your butt that you've ever experienced. And that's where this article will come in handy. This article tells you step by step how to troubleshoot the horizontal section. It's very important. Some horizontal failures are simple, some are not, and you'll see as we go through this thing. If you look at page 54, here's the horizontal circuit. The horizontal circuit is similar to the vertical circuit in that you have the oscillator. That's part of the same integrated circuit. The same integrated circuit that is the vertical oscillator is often also the horizontal oscillator in a monitor. And this is where that 15,750 cycles starts out. Remember the high-pitched squeal that a monitor makes? Well, this is where it starts out. This is the oscillator that generates that. And when you're adjusting the horizontal hold control, you're adjusting the horizontal frequency, just like with the vertical. In fact, it's often called horizontal frequency. The horizontal hold pot is often called the horizontal frequency pot, as it is here in this electrohome monitor. The horizontal frequency. A little dusty here, wait. There, H-freak. See there? Horizontal frequency. These little pots are really delicate, man. You got to be careful with those things.
Is it best to use one of those plastic wands?
Not necessarily. You can use your finger or a wand, but it's, boy, they're really delicate, I'll tell you that right now. Whoa. Ooh, really close. All right. So the horizontal circuit starts out with the horizontal oscillator, but the horizontal oscillator isn't strong enough to drive everything by itself. It has to be amplified first, and so there is a transistor called the horizontal drive transistor. The oscillator is here in this integrated circuit. That drives the horizontal drive transistor. It's usually just a medium-sized transistor. This happens to be the TO127 package, I'm not sure. Maybe TO202, I'm not sure. This one's been replaced too. Look, that's also an NTE part. See that? Kind of surprises me because that transistor doesn't fail too often, although it does fail occasionally. Now, if you look at the schematic diagram, the drive transistor actually drives a small transformer, and that's this guy right here. This is the horizontal drive transformer. Let's look at it from the bottom. There it is, T501. You can see the schematic symbol printed right on the board there for the transformer. Seen bad solder joints on this more than once. And of course, that keeps the horizontal circuit from working. And then the horizontal transformer, the drive transformer, powers the horizontal output transistor, which has also been replaced on this one. See, it's an NTE89. So a lot of work been done on this one. There's the horizontal output transistor. So there really are only two transistors in the horizontal circuit. the IC and 2 transistors. The horizontal output transistor is the hardest working transistor in show business. The horizontal output transistor works really, really hard. Fully 80% of the current, or the power I should say, consumed by a monitor goes through that horizontal output transistor, because it not only drives the horizontal circuit, making the beam move left and right, but what else does the horizontal drive? High voltage, sure, the high voltage unit, sure. Oh, wait a minute, Ken, here. There we go. Good, there you go. Sure. It also drives the high voltage unit, which powers the whole picture tube. The high voltage unit is responsible for powering the picture tube, and we'll take a closer look at that later on. So it really works really hard. As a result, it fails a lot. It fails a lot. Now, remember we talked about loss of vertical deflection, and we said that if you have a loss of vertical deflection, you just have a horizontal line on the screen, right? What is the symptom of loss of horizontal deflection? Nothing. Why?
Because you don't have no high voltage.
No high voltage, right? Remember that? In fact, you will probably never see a vertical line on a monitor. It just really doesn't happen unless the yoke wire has fallen off or the width coil has broken. Because when the horizontal circuit fails, horizontal drives the high voltage, no picture, right? Okay? As a matter of fact, when the horizontal circuit fails, it usually blows the fuse. In fact, it's one of only three things that will blow the fuse in a monitor. I was holding up a toe, you just didn't see it. There's really only 3 things that will commonly blow the fuse in a raster scan monitor. And in order of how often they happen, number 1, the horizontal output transistor. And I'm going to show you a way to check it in just a fraction of a second here. Horizontal output transistor, XSTR, transistor. Number 2, the high voltage unit. And last and way least, and I mean it is just hardly ever going to happen, the diodes, the bridge rectifier really is what it usually is, in the B+ power supply. You know, the main power supply in the monitor. You know, the AC power comes in, and the first thing it does is go to a bridge rectifier, but through the fuse. But that is really rare. As a matter of fact, number 3 will probably only happen if you try powering a monitor without an isolation transformer and you short the chassis to ground. That's what blows these diodes. Other than that, I've never seen these diodes actually fail by themselves. So really, when it blows the fuse, we're talking about these 2 things. And here's how you can check the horizontal output transistor in just a tiny fraction of a second. The horizontal output transistor is always located right near the high voltage unit. And in this case, it's here, and the high voltage unit's right here. Same thing here. In fact, these 2 monitors are almost identical, really, as far as layout is concerned and stuff. Horizontal output transistor. You can see how beefy it looks. See how thick and fat it is? And then, of course, the high voltage unit right next to it. Well, here's how you can check the horizontal output transistor. When it fails, it always shorts collector to emitter, just like the transistors in the switching regulator power supply. To test the horizontal output transistor, all you have to do is put your meter on the diode test setting, and ground the black meter lead to the chassis. If you look at the schematic diagram on page 54, you see that the emitter of the horizontal output transistor is grounded, isn't it? See how it's grounded? If I put my meter lead on ground like that, my meter lead's attached to the emitter, isn't it?
Right.
Well, physically speaking, the collector is the case, isn't it? If I touch my red meter lead to the case, with the black lead on ground, I'm checking from emitter to collector, right? Okay, I should not see a short circuit. What I should see is basically an open reading, like that. If the transistor's good, you see that. If it's bad, it sings at you and says, I'm bad, I suck. That's bad. That's good. You're seeing capacitor charge up there. Boom. So, when you get to a monitor that has a blown fuse, don't freak out. Don't be going, oh my God, the fuse is blown. Oh God, now our life's ruined. No. You should be jumping for joy because that fuse is telling you exactly what's wrong. That horizontal output transistor is more than likely bad. Now, there's a real good possibility that the high voltage unit is also bad. You should, whenever you have a horizontal output transistor failure, you should always examine the high voltage unit and see if it's good or bad. And usually they look bad. When you have a bad high voltage unit, it usually looks bad. And if we take a look at this one, well, just kind of wait a second. Jeez, I'm just trying to pose for the camera. You see the big old cracked, burned up mark on here? I think it's mustard, as we say. It's wasted. Okay. It'll either look like that, it'll be all cracked. Here's an obvious crack. See that? Or it will be melted and bulged out, looking pretty nasty like this. So that's pretty dang bad. And usually you can see when they're bad. Usually when you have a bad high voltage unit, it looks bad. You can see that it's obviously cracked or burned. Now, it may not always look bad, though. It may not always look bad. So this is very important. Listen to me. Listen to my words. Words of wisdom. When you find that you have a bad horizontal output transistor, you're going to put the new transistor in. Always examine the high voltage unit, make sure it looks good. So let's say it looks good. You put the new fuse in, you got the new horizontal output transistor in. When it comes time to test the monitor, turn it on for only a split second and turn it right back off again. In other words, if you have an interlock switch on the game, on, right back off. Or if you're plugging it in, plug it in, take it right back off again. During the time that it's plugged in, listen carefully. Do you hear the squeal? Do you hear the static crackly build up? If so, great, you fixed it, everything's cool, plug it in, watch it warm up. But if in that split second that you had it turned on, you didn't hear the sound, you may still have a bad high voltage unit. You may just not see it. It may not be bad enough to see. Feel the horizontal output transistor. Just touch it with your power's off now. Just touch the case with your finger. If it's warm at all, your high voltage unit really is bad. It really is bad. It's just not bad enough for you to see it. The reason you're turning it on and right back off is that by doing that, maybe you won't blow out the horizontal output transistor you just put in. Now you'll notice that the horizontal output transistor has more than just a transistor in it. The horizontal output transistor also has a diode built in, like the Darlington transistor did. It's a safety diode, it's a protection diode. In a monitor, it's called a damper diode. It's critically important that the transistor you put in the monitor has the damper diode built into it. The only ECG or NTE part that works is a number 89. As you saw, that's what's in that one, in fact. I do not recommend that you get horizontal output transistors from ECG or NTE because they'll be $12 or $14 a piece. This is one part especially you got to get from worldwide component distributors. They're only a couple of bucks. In the back of your book, and I pointed these guys out to you before, on page 82, worldwide component distributors, 18 Stern Avenue, there you go, Springfield, New Jersey, 07081. I'm telling you, they're really great, okay? Just go to New Jersey, give them a call. They got a toll-free number, 800-222-6268. It's very important to be able to tell that you have high voltage. Really way important. Turn in your, excellent, nice job, all right. Turn in your book to page, oh gosh, 56. If you look at the schematic drawing on page 57 of the high voltage unit, let's see what's inside it. You can see that the main part of the high voltage unit is a transformer. You'll notice that this transformer, instead of having a solid line for the core, has a dotted line. That means that the transformer core material is not iron. It's instead the core of the high voltage unit. The transformer in the high voltage unit is made of a material called ferrite. I'll pass this around so you can take a look at it. It's not iron. It's kind of a compressed, kind of a ceramic iron mix, basically. It's called ferrite. The core of the transformer in our switching regulator power supply is made of the same material. It's called ferrite. Well, in the high voltage unit, that transformer is commonly called the flyback transformer. The transformer that's part of the high voltage unit is called the flyback transformer. It's called the flyback transformer because you recall that the horizontal circuit drives the high voltage unit. And the way it makes the beam moves, it moves from left to right, and then it quickly flies back to the left again. The spot quickly flies back to the left. Flyback transformer. As a matter of fact, a lot of people call the high voltage unit the flyback transformer. Although technically it is more than just the flyback, because in addition you see that there are the diodes I was referring to earlier, and some resistors, and there's even a little capacitor in this one as well. So the high voltage unit is more than just the flyback, but a lot of people refer to that thing as a flyback. And if you do, that's okay. Everyone will know what you're talking about. It's the high voltage unit is the flyback plus the diodes plus everything else that's inside it. But if you call it the flyback, that's perfectly okay. Well, what I especially want you to see is if you look at the schematic diagram on 57, let's look at the outputs of the flyback, the outputs of the high voltage unit. And on the top you see second anode. That's the very, very high voltage, the EHT. It also creates a focus voltage. It creates the screen voltage. But one more thing, yeah, right underneath the screen, do you see the winding there, the second winding up? What does that go to? The CRT heater. This is an important concept here. In a monitor, the heaters, the things that you see glowing down here in the neck of the picture tube, are driven off of a winding on the flyback transformer. You know how a lot of people, when they want to see if a monitor is turned on or not, you know, they'll look down here and they'll say, well, you know, do I see a glow? Yeah, I see a glow. I know it's on. Well, certainly if you see the glow, it's definitely plugged in and turned on. But just because you don't see the glow doesn't mean it's not turned on. The CRT heater is driven off of a winding on the flyback. if for some reason you lose high voltage, you're also going to lose your heater, aren't you? That's really important. Just because the heater's not lit up and the screen is blank doesn't mean you don't have high voltage. You may have some other problem. Don't go sticking your tongue in different things in there, because you can get a shock off of that thing. But what this also means is that if you do see the heater glowing in the neck of the picture tube down here, you do have high voltage. Because there's nothing that's going to cause the heater to work but not have high voltage. So, and there's a possibility that you'll have a blank screen but still have high voltage. So, like if the blanking if you have a blanking failure, and if the filament circuit's not working, you'll still have high voltage. So, but if you do see that there's a glow in the neck of the picture tube, then you must have high voltage. Your high voltage has got to be there. You know, it is possible, I suppose, that the high voltage winding would be broken, but the low voltage would still work. I've sure never seen it. High voltage units fail catastrophically when they fail. They do what we saw. But it is really important to be able to tell if you have high voltage, and if that you have it continuously. I'm going to talk more about this tomorrow morning, because it's one of the things that can be very complicated, and I want you to understand what I'm saying. But it's really important that you be able to tell you if you have high voltage. Certainly, if you can hear the squeal, you have high voltage. If the heater's on, you have high voltage. And obviously, if you see something on the front of the screen, you have high voltage. But here's another really cool way that you can tell if you have high voltage. You've got a coffee stirrer here, and this little bulb, this is a neon lamp. And we can use this to determine if we have high voltage. If I hold the lamp near the high voltage unit, it will glow. Mira. Okay, see? See it glowing there?
Yeah.
Ooh, ah, ooh, ah.
Science at work.
Now, really, you don't need the straw. The straw has nothing to do with it. I can hold it, in my fingers. But to most of you, the idea of thrusting your fingers adjacent to the live high voltage unit maybe is a little bit more than you can handle, and so you may not want to do that. Anyway, but this is a really cool deal. This is a little neon lamp. It's very fragile. If you break it and you need to get another one, you can get them. Even at Radio Shack, they have them. They're like 2 for 89 cents or something like that. It's an NE2 neon lamp. The reason that it's important to have the little magic wand. Get the other half of my magic wand, and you probably want to tape this on, actually. I mean, if you bend the leads up, you can kind of jam it in there and it'll stay in there, but it's really not a bad idea to put a little tape or glue or something on it. It stays in there, but anyway, the reason that you need to have some way to tell if you have continuous high voltage is that there is a possibility of a problem with the monitor where the monitor will come on for a split second and go right back off again. And it's on long enough to charge up the picture tube, so that if you were to turn it off and try discharging it, you'd hear the snap of the spark and everything. But it's not on continuously. This is what I need to talk to you about tomorrow that I will not discuss now, because it's just not going to make sense to you. I mean, already Claude's going, oh my God, I don't know what the hell's going on, and I'm sure some of you are too. By holding this against the high voltage unit, you can tell that you have continuous high voltage, and if you have a problem where the screen is blank, and you can't hear, you're in a real loud environment or something like that, you hold that up there, man, if that sucker's glowing, you definitely have high voltage. It's a real important tool. Yeah, Dan?
You're doing that with that off, right?
No, it's on. No, the monitor's on. Monitor has to be on, sure. See if you have high voltage, absolutely. The monitor.
If you physically touch that bulb to that transfer, will it pump the bulb?
No, I am touching it right up. I'm putting it right up against it. Here, let me give you another view of it. In fact, the best thing is for us to just come up here and try it here.
It's not necessary to touch it, right?
Now, the further away I get, the dimmer it is. Here, hey, we've got a couple minutes. Why don't you guys come up here? One at a time. Come on, guys, up. Come on up here.
Doing something that's not great.
You wanna check on that,
They have it,
Okay? Most of the adjustments in a monitor are potentiometers. Things like vertical hold and vertical size and all that stuff are potentiometers. But the width control is not. The width control is a coil. Oh, that's right. You have a brand new coil here. Yeah, that's really cool. Thanks. In a monitor, the width control is a coil that looks like this. And deep down inside that, oh, here we go again, here we go. Deep down inside that coil is just space. Right there. Deep down inside there, there's something called a slug. Oh, there is something called a slug in there. That's right, and there it is, right there. Okay. So anyway, and you can kind of get another look at it right here. Here's the width coil right there, and there's the slug sticking up. You'll notice that it looks like you can put an Allen key in there, like it's a hex head thing, and this thing unscrews. I don't have the tool with me at the moment. This guy unscrews and goes in. In other words, it withdraws or goes into the the core. Sorry, the core or the slug goes into the coil or out of it. The further into the coil it is, the narrower the picture is. As you withdraw the slug, the picture gets wider. Well, it looks like you can use like an Allen wrench in there. Don't even think about putting a metal tool in that baby. Okay, this is really important. It has nothing to do with getting shocked. You're all going, oh, well, yeah, I won't get shocked off of that. That ain't the reason. The reason is that it's like putting metal in a microwave oven, isn't it? The second you stick that Allen key in there, it starts to heat up. What happened to me was I got to this game, and the picture was not the right width. I forget whether it was too big or too small. I didn't have my plastic tool. There's a plastic tool called a hex alignment tool you have to have. You can get a whole set of them from Radio Shack for like cheap. So I thought, well, I'll use an Allen wrench. I put the Allen wrench from the back, I put the Allen wrench in the thing and I turned it a little bit. I went to the front and I went, holy mackerel, the picture is really small now. Well, as soon as I put the metal tool in there, the picture went like this. So I went, wow, that's pretty weird. I guess I turned it the wrong way. And I go into the back. Yeah, shit, I got this L-shaped thing burned into my finger from this thing. It gets really, really hot. If for some reason you don't have the plastic tool, which you really should have, you can adjust it with the Allen wrench if you're really careful. You have to turn it off, adjust it a little bit, pull the tool out, turn it back on, see how it's going. But I don't suggest you do that because there's a real excellent chance you'll crack the core with that metal tool. So you really need to use the plastic hex alignment tool, and you adjust the coil or the slug that way. If you cannot get the picture wide enough or small enough, but usually you can't get it wide enough, there is a modification that you can make to the monitor. Perhaps this has happened to you. Have you ever done a Japanese conversion kit and the picture's like really narrow and you can't get it to fill out the whole screen? A lot of the Japanese games use a faster horizontal scan time. Instead of taking the full 60 microseconds, they maybe only go 55 microseconds. The less time, the narrower the picture is, and you just can't adjust the width out. If you turn to page 60, on page 60, if you look at the schematic diagram, here's the horizontal size coil, aka the width coil. Horizontal size, also known as the width coil, same thing. And you see that in series with it, going to ground, there's a capacitor there. That's the AC return cap. It's the return path thing that we've been talking about all week. Well, changing the value of that capacitor affects the size of the picture. Basically, if you make it a little smaller, the picture gets bigger. You make it a little bigger, the picture gets smaller. And the last paragraph here, although it kind of got punched with some holes in it, tells you which capacitor to change in which monitor. basically, at the most, you'd want to cut it in half and make the picture much bigger. And usually what I do is I go through my junk monitor chassis and I just salvage some cap off of a junk monitor, and that's a little bit smaller and it makes the picture bigger. So if you cannot adjust the width, that's a good way to actually change it, simply by changing that value, changing the value of that capacitor. Okay. Well, let me back up a little bit. Let's look at some of the things that we've got in here. Turn back to page. Turn to page 49. And let's look at some of the odds and sods I've got going here. Some of the little odds and ends, some of the weird stuff that's in this book. As I mentioned on the first day, there's lots of things in this book that maybe I won't even cover. You know, maybe you ought to leave this in the bathroom for a little while, you know, and then every morning you can get smart and stay regular or something. Anyway. Okay, on page 49, I do this occasional column that I call repair log, just some bits and pieces of different things. And one is how to flip the picture upside down. Occasionally, you may have a reason to do this. And when you need to do this is when you have a vertical game, where you have a vertically mounted monitor. The game manufacturer doesn't really know which way you have the monitor mounted when you have a vertical game. In other words, be really careful here. Is the monitor mounted like this in the game, or is it mounted like that? They're both vertical mounts, but you know, one's going to make the picture be upside down. So there's a way that you can modify the monitor to flip the picture upside down. Most kits have a dip switch that says picture invert or picture flip. So really, you might never have to do this. But if you have to, you don't ever want to rotate the yoke. What some people do is they'll loosen the clamp on the yoke and just rotate it 180 degrees. It flips the picture upside down. That does work. But the position of the yoke is critical to the alignment of the three guns. And if you mess with the yoke, you're going to split up that convergence and you're going to really have a lousy looking picture. Instead, you do it electronically. And the way you do it is like this. And it's very simple. Here's the yoke. And the yoke is two pairs of coils, but we can kind of think of it as two coils. One is the vertical deflection coil, and the other is the horizontal deflection coil. If you check with your meter, you'll see that they are two different resistances. The horizontal deflection coil has a very low resistance. It may be anywhere from 2 to 4 ohms. The vertical deflection coil will be higher, anywhere from 8 to like even 32 ohms. Well, you don't really care which coil is which. You just have to identify the pairs of wires going to the yoke coil. You have to identify which is the vertical pair and which is the horizontal pair, and this little article tells you how to do that. Basically, you just use your meter on ohms to figure out which is a pair. Obviously, between here and here, I get no continuity. You know, between here and here, I do. Oh, that's a pair. Well, anyway, to flip the picture upside down, all you have to do is reverse the wires. And that flips the picture upside down. Unfortunately, that also turns it into mirror writing. It turns it inside out as well, and so you do have to do them both. You reverse the wires on one, you reverse the wires on the other. And that flips the picture upside down. Now, one really incredibly clever thing that some people do is this, and I've done it to this monitor, not to be clever, but because I just needed to do it for demonstration purposes. You can split the yoke connector on the monitor. And that's what I've done here. Here's the yoke connector. The red and blue wire are for horizontal, the green and yellow are for vertical. That's actually somewhat standard, but not totally standard. I split them apart. All you have to do is reverse them, turn them around. Put this one in like this instead. If I put this one in, it reverses horizontal. If I flip this one around, it reverses the vertical. So you can see here where the two were originally joined together. You can see where I cut them apart there. You simply have to reverse them like that. That one, reverse this one as well, and it flips the picture upside down and inside out. Well, basically upside down is really what you're interested in. So the point I'm making here is don't mess around with the yoke other than reversing the wires. No problem. Reversing the wires, that's no problem at all. It's a great thing to do. It's wonderful. Do not just rotate the yoke because you'll throw it out of convergence. There's a couple of other things in here about Hunter X monitors. Forget about those for now. Turn to page 51. And here's a compendium of symptomology. Figure 2 shows the blanking problem. You get to the game, the screen is blank, black, blank. Game coins up, makes all the game sounds, meaning you have a monitor problem. You reach in the back of the monitor, crank up the screen control, and this is all you see. Raster with the lines called vertical retrace lines. Yeah, well, good, Cheryl. Ooh, this one's really melty, but see how I can do with a left-handed toss. Oh, shitty. Okay, sorry about that. I just wanted to see you grovel. All right. Now, and so that's transistor X304. I mentioned that before. Figure 1A and 1B. This is a very common problem. There's a common problem with monitors, and it's another one of those capacitor problems where the picture is distorted. Remember I mentioned distortion is capacitor failure. Let's see, here's the picture tube. Normally the sides of the picture are supposed to be perfectly straight. There's a problem called keystoning, where the sides of the picture, instead of being straight, are pulled in like this. They're kind of pulled in at the bottom like this. This is called a picture that is keystone. It's called keystone. It has nothing to do with the Keystone Cops or anything else. It's called keystoning because when you build an archway out of bricks, the way you make it is you tilt the bricks up a little bit each time, like this. You tilt them up a little bit more, like this. If I can do this here. The top stone is shaped like this, the keystone of the arch. It's a thing that holds the arch together, and it looks just like that. Anyway, this is a capacitor failure. It's capacitor C517 and C518 in the Electro-Home monitor. It's one of the, it's those caps that are, some of those caps that are included in the capacitor kit that you'll get from Zanan Electronics. I replace these all the time. Very common problem. Easy to spot. They're right next to the high voltage unit in the monitor. It's these two here. One is 220 microfarads, the other one's 100. These two little black guys right here. Dead Electro-Home G07, I'm going to cover that tomorrow morning. That's the interesting and complicated thing. I'm going to cover that tomorrow morning. Some other problems, over bright picture. You should be able to turn the brightness all the way down on a monitor. On the Electro-Home monitor, there's another common problem with a capacitor failure. There's a bunch of capacitor failures. On the neck board, there's a capacitor here. It happens to be C107. It's the only cap on the neck board. 10 microfarads, 250 volts. This little guy right here. This one's been changed with a Nitricon cap. Very good. These capacitors suffer from something that I refer to as capacitor leprosy. The capacitor will literally rot right off the neck board. I don't know why. I've opened up games. The capacitor's not there. It's on the bottom of the game. So, it just rots right off. I don't know what happens. Page 58, please. Troubleshooting the Hunter X MTC9000. The MTC9000 is the current version of Hunter X monitors, although they've actually just come out with a brand new monitor they call Polo. I haven't even seen it yet. Anyway, the Hunter X MTC9000 has a big bad problem eating up high voltage units, as you may or may not have found out already. I've replaced dozens and dozens of high voltage units in the MTC9000. You remember the big helping hand resistor that I mentioned before, this big white resistor that's, right here on the monitor chassis. There's a similar one in the Hunter X MTC9000. When the high voltage unit fails, that resistor cooks, like it gets hot enough to make toast on it. It gets really, really hot. If you ever work on an MTC9000, and there's no picture at all, and that resistor, the big resistor, the helping hand resistor, is like enormously hot, your high voltage unit's bad. This article explains why it does what it does. Also, one pretty cool thing about this monitor is that usually you just have to replace the high voltage unit and it does not take the horizontal output transistor out with it. Remember in the power supplies we talked about OCP, overcurrent protection? This monitor power supply has that in it. When the high voltage unit fails and shorts out, the power supply shuts itself down. And that keeps the horizontal output transistor from failing, usually. Occasionally it fails, but usually it doesn't. On the far right-hand column, K7000 updates. The K7000 is the very latest, newest, well, it's really not the newest, it's the current model Wells-Gardner monitor. And here's dozens of common problems and little things that you can do to fix those. I'm not going to go over those in any great detail, because you can read just as well as I can. On page 63 is a step-by-step detailed discussion of, or instructions I should say, on replacing picture tubes. Does tell you everything about how to change the picture tube. I really only have 2 words to say. Good luck. Because it ain't easy. It ain't fun. It's nothing fun and easy about doing it. I suppose the guys in the factory can do it easy. They do it all day, but for me it's never been something that I've been too successful at doing. Okay, and that's really basically. Oh no, wait, sorry, one more thing. On page 69, isolation transformers. People kept asking me why you needed the isolation transformer, and I know that you need it, and it's a safety transformer, and I kind of like to leave it at that. But people kept bugging me. Why, why exactly? And then I thought, well, gee whiz, why do you really need it? What exactly is this thing doing? Because you put 120 volts into it, you get 120 volts out. What's the dang deal there? How can that possibly help you? Well, this is fascinating, I thought. I called up our power companies, SDG&E, San Diego Gas and Electric. I spent about half an hour on the phone with an engineer discussing power distribution and neutrals and ground and how everything's set up, and this explains how you do that. I mean how it works, I should say, and why you really need the isolation transformer. And I strongly suggest you read through it. It's really interesting, I think, how it works. And I want you to admire the really cool computer-generated drawing that I did up here on the top. It only took me 8 hours to do that. But doesn't it look like a telephone pole right on the sidewalk? Isn't that really realistic? There's a little doggy lifting his leg right there. So, all right. Anyway. Okay. Tomorrow, here's what's going on tomorrow. Tomorrow we're going to do the monitor lab. The first thing we're going to do tomorrow is get everything working that we got here that's already here. Vigilante has only red. That's just a cracked neck board. It's just going to take a little time to get that all working. The SkyShark monitor I know needs at least 1 capacitor, maybe more. There's some others in the back room. The monitor lab's a little different than the power supply lab in that you'll work in groups in the monitor lab. You'll work in groups of 3 or 4 people each and kind of work on one monitor together. After we get all these monitors working, I'm going to put another set of problems in them, and we're going to go through a second time and go through them again as time allows. I'll keep doing that as long as we have time. So if any of you have more monitors that you want to bring in, tomorrow's the time to do it. And so we'll do that tomorrow. But tomorrow morning, first thing, I will be going over one last thing. I'll be covering something called the X-ray protector circuit and a little bit more about the horizontal circuit, because when the horizontal doesn't work, the whole monitor appears completely dead. It can be very confusing. So I'm going to go over that first thing. Right? I'll see ya mañana. Yesterday, when we left our hero yesterday, we were talking a little bit about the horizontal circuit, the horizontal deflection circuit, and I mentioned that the horizontal deflection circuit can be the easiest thing in the world to troubleshoot. The horizontal output transistor shorts, it blows the fuse. You see the fuse is blown, the first thing you do is whip on that transistor from collector to emitter. Remember that you actually ground the black lead to the chassis, touch the red meter lead to the case of the transistor, and test it. As a matter of fact, when Jeff brought this monitor in, the fuse was blown in it. The main power fuse in this monitor was blown. And the first thing I did was check that transistor from collector to emitter. It was not shorted. The next thing I did was physically examine the high voltage unit. It looked perfectly okay. The next thing I did was check the diodes in the B+, the 4 diodes that form the bridge rectifier where the AC first comes in, gets turned into DC. Those were okay. After checking all those, I said, what the heck, let's put a new fuse in, see what happens. I put the new fuse in and it works fine. So I don't know what blew the fuse to begin with, but I checked the only 3 things that I know commonly blow that fuse, and they were all okay, so I didn't hesitate to stick a new fuse in. And the monitor's working perfectly okay. So I don't know what the hell is going on there. I mean, it's pretty obvious that it's working perfectly okay. But other types of horizontal failures can be very difficult to troubleshoot. So let's turn back to that article on troubleshooting horizontal deflection failures, which is on page 53 in your big blue book of really great technical information. Here's the deal. When you have a horizontal failure that does not blow the fuse, the monitor does appear completely dead, doesn't it? Remember, there's no squeal because that comes from the horizontal. Also, there's no glow down in the filaments of the picture tube. Remember, the heaters, the CRT heaters, are driven off of a winding on the high voltage unit, on the flyback transformer. Since that's driven by the horizontal circuit, if the horizontal's not working, you don't get any heaters at all. So the monitor does appear completely dead, and that can be rather confusing. The first thing you always want to do when you have a monitor that appears completely dead is check the power supply voltage. Check the voltage of the B+ power supply, which you'll check at that big helping hand resistor. You remember the large white resistor that I showed you before? One side of it is the unregulated input, the other side's the output, and all you have to do to measure that voltage is ground the black meter lead to the chassis somewhere and carefully touch one side of the resistor. It happens to be the side closest to the picture tube in this particular monitor. That's the regulated output. See if you have anything there. If the horizontal circuit is not working, however, the power supply voltage regulator will also not work. And this is what can be somewhat confusing. So this is why I waited till this morning to point this out to you. If you recall the power supply, we have the diodes, we have the filter capacitor, then the series pass regulator transistor. And then we've got this helping hand resistor, like this. Oh, in let's say, for instance, the electro-home monitor, the unregulated input voltage on this side of the resistor will generally be around 145 volts DC. The regulated output, the B+, as they call it, should be 120 volts DC in the electro-home monitor. It will be 130 in the Wells Gardner 4900 series, depending on the monitor, a little bit different. And of course, this goes to all of the monitor circuits. You know, it's your main power supply. It powers everything. Everything in the monitor gets powered by this guy here. And remember I mentioned before that the purpose of this helping hand resistor is to carry some of the current across it so that the transistor doesn't have to work so hard. I also mentioned that the horizontal deflection circuit in the monitor draws more current than anything else. Remember that? The horizontal deflection circuit in the monitor draws like 80% of the power. If something happens and the horizontal deflection circuit is shut down or not working, there's not really any significant amount of current being drawn across this voltage regulator. As a result, it doesn't work. Because of the helping hand resistor, actually, when the horizontal is not working, not blowing the fuse, but I mean just not working, the B plus will probably rise to around 160 volts DC. And in fact, so will the input. The input will rise as well because we don't have any current, any significant amount of current being drawn, and so everything stays at a very high level. This can be rather confusing because you get to the monitor and it does appear completely dead. You get to the monitor, it appears completely dead. And yet you check the power supply voltage and you've got tons of voltage there. You've got even more than you expect. So that's confusing thing number one, because you're getting to the monitor, it's completely dead, and you're thinking, well, I don't know, is the power supply bad? What's, you know, how come I don't have anything? The monitor doesn't make any noise, it doesn't do anything. But you check the power supply voltage, man, you got a shitload of voltage there. You got more voltage than you need. You know, what the hell's going on here? Okay, everybody with me so far? And perhaps the reason that you have too much voltage there is the fact that the horizontal circuit's completely shut off. Okay, remember that for just a second. Now let me step to one side here and present you with another concept here. In a monitor, we'll get back to this in just a second. In a monitor, if the high voltage goes too high for some reason, the monitor can emit what's known as soft X-rays. If the monitor, if something happens and the high voltage goes too high, the monitor emits these things called soft X-rays. And this is a hazardous deal. So to prevent that from happening, most monitors have a circuit in them known as the X-ray protector. It might also be known as high voltage shutdown. It might simply be called protect. It might just be called shutdown or something like some similar name. What the X-ray protector circuit does is detects if the high voltage has gone too high. And if it has gone too high, it turns off the horizontal oscillator in the monitor. The X-ray protector says, holy mackerel, the high voltage is too high, turns off the horizontal oscillator. Well, the horizontal oscillator is the start of the horizontal deflection circuit. If I turn off the horizontal oscillator, it turns off the whole horizontal circuit, which of course kills the high voltage too, right? Because the high voltage is driven off of the horizontal deflection circuit. So immediately, as soon as the X-ray protector circuit activates, the high voltage goes off. Everything shuts right down. Now, what can cause the high voltage to go too high? Well, not much. In general, the only thing that causes the high voltage to go too high in a monitor is if the voltage regulator fails. If the voltage regulator fails and puts out too much voltage, that makes the high voltage that much higher. In other words, if the B plus, instead of being 120, is 150 or something like that, the high voltage will also be too high, and it'll shut off. I mean, it'll emit the X-rays. So we don't want that to happen. The X-ray protector circuit, it depends on the monitor that it's in. The X-ray protector circuit is actually either monitoring the B+, or in many games, in many monitors, it's monitoring the X-ray protector circuit is looking at an output from the flyback transformer. Not the high voltage output, that's too high, we can't mess around with that, but another winding, a low voltage winding. And of course, if the low voltage winding on the transformer is putting out too much, so the high voltage winding is too, naturally. So, but in general, what causes the X-ray protector circuit to activate is if the voltage regulator in the monitor goes too high. It fails, it shorts out, puts up too much voltage. Okay. Well, here's the confusing thing. You get to the monitor, and it appears completely dead. You measure the voltage here, and you find that it's 160 volts. Question, which came first, the chicken or the egg? Is the regulator bad, and that's activated the X-ray protector, shutting off the horizontal? Or is the horizontal circuit simply not working, and because it's not drawing enough current out of the regulator, that's why it's too high? Okay, one more time. Here's the confusing part about this. In either situation, the voltage at the power supply is too high. Either the regulator is really bad and it's putting out too much voltage, which has activated the X-ray protector, thus shutting down the horizontal circuit. No noise, no nothing. Or the horizontal circuit just ain't working, it's broke, and because it's broke, it's not drawing enough current and the regulator is too high. So now you got to figure out which is which. You have to figure out where a problem is. And here's what happens, and this is why I'm pointing this out, and I don't want you to do this. Some people, when they find that the voltage here is too high, automatically start working on the voltage regulator circuit, which is very logical, isn't it? Because if the voltage is too high, you'd think, well, the regulator's bad. Maybe that's not why it's bad. I mean, maybe that's not why the voltage is too high. Maybe all the parts in the regulator circuit are perfectly okay. And I went around and around in circles the first couple of times I went through this, because, you know, I essentially changed every part in the regulator circuit, and the problem still was there, so I knew that it was a horizontal problem at that point, but there's an easier way to do this. When you get to a monitor that is completely dead, of course, you've checked the fuses and everything. The first thing you do is check the power supply voltage. On finding the power supply voltage to be too high, we want to determine if it's a regulator problem or a horizontal problem. What you do is disable the X-ray protector circuit. Turn to page 54. And on the very top of page 54 shows you the different methods of disabling the X-ray protector circuit in different monitors. For instance, in the Electrohome monitor, you remove transistor X701. That's the X-ray protector transistor. You just pull it out and take it out. Other monitors, you might remove a diode or something like that. With the X-ray protector circuit disabled, you turn the monitor back on. If the monitor then fires up and you get a picture, the horizontal's got to be working okay, huh? And what you'll see is a picture that's probably a bit too large and a bit too bright, and maybe that squeal is very loud because the regulator is shorted and you got way too much voltage on everything. Naturally, you don't want to spend a lot of time hanging out in front of a monitor with a disabled X-ray protector. But that X-ray protector and the X-rays that come out, it's really to prevent long-term exposure to that. There's really, as far as I know, no major problem with just turning a monitor on for a split second with the X-ray protector disabled, and that's all you do. You just turn it on, you hear the squeal come up, you know that the horizontal's working okay, then you fix the voltage regulator circuit. On the other hand, if you disable the X-ray protector circuit, and there's still no monitor activity, no sound, no picture, no nothing, then obviously your horizontal circuit really is bad, and then you troubleshoot the horizontal circuit. Does this make sense? You're trying to figure out which is which. Now, if you're very observant, there's a way that you can not have to go through all this hassle. This is the legitimate way to do it, but there's another way that you can do this in most monitors. And this is where your magic wand is going to come in really handy. When you first turn the monitor on, if you listen carefully, Or if you hold your magic wand near the high voltage unit, if the problem is that the voltage regulator is bad, the monitor will come on for a split second and go right back off. Very important. Listen to what I'm saying here. When you turn the monitor on, you'll hear it go squeal, and that'll be it. You'll hear a momentary squeal, if you can hear it, and you'll maybe hear that static, crackly buildup, but then it'll go right off again. If you ever hear that, despite the fact that it's gone off, the horizontal section's still perfectly okay. If it came on for a split second, your horizontal's working okay. You have a voltage regulator problem. The X-ray protector circuit has detected that and said, holy shit, shut off the monitor, quick, X-rays, you know. And if you're in a loud environment and you can't hear that, that's where this is cool, because you'll see it flash. It'll just go flash, that'll be it. It'll blink once, and that'll be all she wrote. The reason that this unbelievably cheap tool is so important is that what a lot of people will do to determine that they have high voltage is turn off the monitor and then, using the grounded screwdriver, try discharging the second anode. Well, you can't do that because the high voltage is on long enough to charge up the picture tube. Even though the voltage regulator is bad and the X-ray protector's been activated, it does squeal for a second and builds up the high voltage charge. It's enough to discharge the picture tube. You'll definitely hear a snap when you go to discharge the picture tube, but you never really had high voltage for any period of time. This is why people get confused, because you can hear it come on, but you may not hear it go off. You hear it come on, and you're waiting for it to warm up, and you're waiting, and you're waiting, and you're waiting, and it just never warms up, and you think to yourself, well, wait a minute, I heard the high voltage come on, but it's not on. But I heard it, but it's not there. What the hell's going on here? How come I don't, how come it's not warming up? And the reason is, you can hear it come on real easily, but you can't hear it go off as easily. But if you have the magic wand, you hold it near the high voltage unit, you'll definitely see it'll just blink, and it'll go right off. If that happens, if that thing blinks and goes right off, you probably have a voltage regulator problem. Now, in a lot of our monitors now, the voltage regulator is an integrated circuit, as it is in this monitor. In a lot of monitors, the voltage regulator is just an IC, like the 3-terminal regulator that I showed you. The integrated circuit is like a 3-terminal regulator, only it probably has 4 terminals on it, but it's just an IC regulator. It's a very common problem to have that fail, especially in the current Wells-Gardner monitors. The K7000 monitor, the newest Wells-Gardner, the latest modern version of the Wells-Gardner monitor, has a chronic problem with voltage regulator failure. And you'll get that exact symptom. The monitor will go squeal, and it'll shut right off again. The X-ray protector circuit has been activated. Okay, does this make sense? So the first thing you do is determine where the problem is. Power supply or horizontal. Once you've determined that it's a horizontal problem, you are now faced with what is probably the most complex of all repairs. Because everything does appear completely dead, but fortunately, it's not that difficult to troubleshoot even without an oscilloscope if you follow a logical step-by-step procedure. And starting on page 53, this whole article, it does tell you step-by-step how to do this. And I just want you to be aware of where this article is, because if you have this problem, you're going to need to look this up. I'm not going to go through this step by step because it is all completely detailed for you here, number one. Number two, you may never see this problem because it's catastrophic horizontal failures that are not simply the horizontal output transistor failing are very rare. Most of the time, it's simply the horizontal output transistor that fails. But in a nutshell, what this article tells you to do, for instance, is measure the voltage. And in this case, you will be measuring a few things with the power on, so you have to be careful. It does tell you to, for instance, first measure the voltage at the horizontal output transistor with the power turned on. If it's missing, it tells you to look for cracks here or bad solder joints there. If the voltage is there, it tells you to move to the horizontal drive transistor and check that. Check the voltage here, check the voltage there. If it's missing, check some other voltage. It tells it to you step by step how to do it. To be quite honest with you, I don't really get much feedback from people in the field about the technical stuff that I write. But I've gotten more feedback on this one article than anything else. So about 6 months after it came out, I had a bunch of people come up to me at one of the trade shows and say, "Oh, Randy, you know that thing you wrote about horizontal? Yeah, I fixed like 6 monitors. It was really great." And in the monitor lab sessions that we've done in the class, we've been able to use it with 100% success about 3 or 4 times. Like I said, it's not a very common failure. And so it'll take you step by step through the most difficult of, which isn't really that difficult once you know what to do, the most difficult of monitor repairs. Essentially, if you look on page 54 at the schematic diagram, again, when you troubleshoot something, you generally start at the output and you work your way back, and it's going to tell you to check the voltage at the collector of the transistor, then to move back to the horizontal drive transistor, check that transistor, check the voltage on it, and if all that stuff tests good, it's going to tell you to change the integrated circuit where the horizontal oscillator lives. I've only seen this fail like a couple of times, and every time I've seen it fail, it's because somebody didn't have the monitor chassis mounted correctly. When we do our lab session, when you fire up monitors, you're gonna make sure that the monitor chassis is sitting mounted properly in place. What happened was they had it like out like this, and the metal part of the chassis touched the bottom of the IC, which is right there. That's exactly where it rests, right on the chassis, and it blew the IC. That's happened 3 times. So does this kind of make sense? I know it's fairly complex, but okay. Regardless, if you forget all of this stuff, it is really written down for you right here. Which brings us to another thing that I want to point out to you that I bypassed yesterday. Sorry, stand by. Go back to page 51, please. Dead Electrohome G07. Dead Electrohome G07. There's one real common problem in these Electrohome monitors, and it's failure of one of the capacitors. It's this one right here, and this one is bad on this monitor. Okay, this is the Electrohome G07. This is the way you see it from the back normally, like this. And of course the picture tube's up here. And way up here is capacitor C511.
Yep.
Okay. What can you tell me about that cap right now?
Shrink is scaling back.
It's bad, isn't it? The top is shrunk. See that? See how the top is completely exposed on this one. In fact, this one's on its way out too. So's this one. You know, this one looks okay. You can see the top on that one's okay. Let's see if we got the capacitor leprosy problem. Ah! Remember I told you it rots right off the board? There's where it was. Right there. That's where that cap usually lives, right there. It's gone. See, the leads are still there. All right. Anyway, okay, this is capacitor C511 on this Electrohome monitor. This is a common failure. And when capacitor C511 fails, it causes the X-ray protector circuit to be falsely triggered. Now this is really important. And of course, if you get one of those capacitor kits from Zanon Electronics, this problem will automatically go away because that's one of the caps you get. It's probably the main cap that you always want to replace in Electrohome anyway. But here's what this cap is for. This capacitor is connected in the circuit electrically right here. It's 47 microfarads, 160 volts DC. It's a cap that I always have with me. I always carry this cap. Very important one to have. I suppose it's technically called a secondary filter capacitor. It's electrically located right after the voltage regulator. It's physically located fairly close to the high voltage unit. You know, it's like it's over here here's the voltage regulator circuit on this side of the board. Whoops. Here's the voltage regulator on this side of the board over here. But this cap is really located over here near the high voltage unit. And here's what it's for. And I point this out to you because it's the same in many other monitors. Similar problem. As the horizontal output transistor switches on and off, which it's doing at 15,750 cycles per second, it generates huge voltage spikes. Here's 0 volts. Here's our pure DC, and the power supply is supposed to be 120 volts DC in the Electrohome monitor. When that horizontal output transistor turns on and off, it generates these very large voltage spikes, they're called, like this, that travel along the power line. The purpose in the Electrohome C511 and other monitors, there's similar capacitors, is to remove those spikes so that we don't have them anymore. When the capacitor fails, it lets those spikes on the line. Well, what the X-ray protector circuit does is looks at the B+, the power supply, and anything over 138.5 volts, the X-ray protector says, "No, too much, shut down." Well, the power supply isn't really over 138 volts. It's really 120, but it's just these spikes that are traveling on the line. It hits those spikes and it shuts the thing off. You've probably heard similar spikes, maybe in your car, you're driving along listening to the radio, and some guy in an old pickup truck pulls up next to you and you hear this brrrr in your radio. You're hearing his spark plugs firing. He's generating electrical noise. It's the same kind of electrical noise, basically. And so the purpose of the capacitor is to get rid of that. When the capacitor fails, it falsely triggers the X-ray protector circuit, shuts down the whole monitor. So on an Electrohome monitor, if you ever have a problem where you plug it in and it goes squeal and then stops, or your little light flashes next to the high voltage unit, definitely C511 is bad. Whenever I work on an Electrohome monitor, I always replace all those caps all at once. C511, the one on the neck board, there's several of them. That's why it's critically important that you get one of these capacitor kits from Zanan Electronics and just stick them in. Because that way you don't even have to know what the hell's going on. You don't have to troubleshoot anything. When you get the bad monitor, you stick in all the new caps, and maybe that'll fix your problem. You know, because you're going to replace that cap anyway. Now, occasionally I get this complaint here in the lab. People bring in monitors and they say, "Yeah, you know, it just had a little bit of distortion in the picture, so we put in one of those cap kits and now it doesn't work at all." You did something, obviously. If it was kind of working before and it ain't working now, you did something wrong. I've seen this plenty of times. Solder bridges right across the leads of the caps, or some other weird, or you cracked something while you had it out, or something like that. Monitor PC boards are not real sturdy. You got to be careful about these. Never just toss that in your trunk. I have at least 4 or 5 monitor chassis at Area Amusements that are ruined, completely cracked in half, because somebody just threw it in their trunk and then threw their toolbox on top of it or something like that. And I personally dropped one once. I just dropped it, and it landed right on the corner, smashed it to smithereens, completely destroyed it. You know, I just really felt awful. In fact, I ended up giving my boss one that I had as a replacement because you know, the monitor chassis is worth some bucks for sure. So anyway, in many monitors you have a similar type of capacitor. In many monitors, in all monitors, in Hunter X, whatever. If you ever have a problem with shutdown, and you have some kind of weird power supply failure where, and in fact this will make the voltage appear too high when you measure the power supply too, when it's doing that. always look for bad caps and look for this capacitor. It's usually this value. 47 at 160, it may be like 100 at 160, it may be 22 at 160, but it's always right after the voltage regulator. The first cap, electrolytic cap, right after the voltage regulator is a common failure item. And again, I know that I'm repeating myself, but these cap kits make it so you don't have to think about those kind of things. You don't really have to troubleshoot it. You just put the new cap kit in and it kind of automatically fixes it. Okay? Let's take a look at some monitor adjustments here. The monitor adjustments are really pretty simple. On the neck board, in fact, let me show you over here. On the neck board of the monitor, let's look at the color adjustments first. On the neck board, you see a group of 3 adjustments there and 2 adjustments there. When you see things in groups of 3, you're looking at the colors, obviously, red, green, and blue, and that's what these are. And you can see right here G and R and B. Right here, B, G, R. Here, I'll get real close here. These 3 color adjustments are called the cutoffs, and they adjust the amount of each color. How much red, how much green, and how much blue. The other 2 that are together are called the drive controls, and they adjust the amplification or the gain of the cutoffs, or the 3 video output stages. Oh, wait a minute here. We've got, hey, wait a minute, over here. Over here. Yeah, nice crotch shot, thank you. Okay, we have 3 colors, and yet there are only 2 drive controls here on the neck board. What's up with that? Well, what they do is they fix one of the colors with a fixed resistor. Theoretically, what you're supposed to do is, with an oscilloscope or something like that, you're supposed to adjust the other 2 to match the one that's fixed with a fixed resistor. Theoretically, that's the idea. In other words, what you're trying to do is match the gain of all 3 amplifiers so they all have the same amount of color, basically. Well, quite frankly, all I generally do is I set those 2 gain controls right in the middle, the drive controls right in the middle. I just set them straight up and down and just leave them there. That's really all I ever have to do. I'll get back to that in just a second. As a matter of fact, when I'm adjusting a monitor, the first thing I do is I set all the neck controls exactly dead center. So I reach in the back here and physically just adjust them. Doesn't matter what you see. It doesn't matter even if there's any pattern at all on the screen. Adjust the 2 there, and then I adjust the 3 drive controls. Okay, they're all dead center. Then you look at the picture that you have, like whatever the game is. You know, do all the colors look good? And basically what I do is I crank up the brightness and I look at an area that's supposed to be black. Okay, this area is black, isn't it? I just crank up the brightness, and you don't even have to have a pattern going. Here, let me just turn off the pattern generator completely. I turn up the brightness. Do you see gray? Do you see white? You're cool. You got it made in a shade. What you're trying to do is set what we call a gray scale. If, on the other hand, it looks a little green, like that, well, turn down the green. You know, if it looks a little pink, turn down the red. And if it looks a little blue, turn down the blue. Or, if it looks magenta, that looks a little magenta, doesn't it? Well, you've got a choice. You can either turn down the red and the blue, or crank up the green. All you're trying to do is end up with something that looks gray. We're not really worried about flesh tones. You know, it's not like it has to be exactly perfect. As long as you have a good grayscale, you're fine. Then, with the game playing, you know, look at it. Gee, does it look like I want a little more? Maybe the red's not bright enough? I don't know. Gee, okay, let's crank up the red a little bit. You know, if you want real massively bright red, crank it up. But now the black looks red. That's no good, is it? You know? So you just kind of adjust each color to be whatever you want. Basically, if you adjust it so it's a good grayscale, you got it made in the shade. If for some reason you just can't get enough of one color, like red or green or blue, if the drive control, the one of two controls, happens to be the color that you're looking for, crank it up. This is the red drive. See how it makes the red a lot brighter or dimmer, or somewhat brighter or dimmer? Also affects magenta, of course. This is the green one. See how it makes the green incredibly bright there, really fluorescent. Or if I turn it down, like that. So, but you know, almost without exception, if you simply adjust all 5 of the neckboard transistor potentiometers dead center, it almost always looks good. Then, depending on how the picture tube is set up, you know, how good the 3 guns are, that if they're equal or not, you may want to tweak a little more red, a little more green, or a little more blue, or a little less. Now, the way they tell you to do it, the way they tell you to do it in the book is to turn all the controls down to minimum. The way they tell you in the book usually is they say center the 2 drive controls, but turn all 3 of the cutoffs, as they're called, down to minimum, crank up the brightness and see if you have a grayscale, and then adjust accordingly. The reason I don't do it that way is that by putting them in the middle, I can go up or down on any control. I can add a little bit, or I can take a little bit away. If they're already at minimum, all you can do is add. You know, so if they're all at minimum and it looks a little green, I've got to turn up red and blue, don't I? Yeah. You know, it's really kind of nebulous, and it really doesn't make a lot of difference how you do it. I mean, the main thing is that you get a good grayscale, basically, as far as the color is concerned. Now, of course, you also have the brightness, which is the screen control. And I showed you this earlier. On the high voltage unit, or in this particular monitor, it's adjacent to the high voltage unit, there's 2 pots. The top one's focus, the bottom one's screen. And the screen control, you know, simply adjusts the brightness. You know, if the screen is too high, well, it's way too bright. If it's not high enough, then it's too dark. You know, I adjust it so that whatever you see that's black should be just barely black. It should just go black, just barely go black. I mean, that's what I do, you know. I don't know whether that's the right thing to do or not. And then, of course, focus is simply a visual inspection. You just look at it and just focus it. No big deal there. When you focus, look at an area about 1/3 of the way down, or 1/3 of the way up, or 1/3 of the way in. Don't focus at dead center. Don't focus it right on the edges, because it's very difficult to keep good focus all over the whole screen. That's why it's curved, is to keep good focus. If you focus at dead center, the edges might be pretty far out of focus. If you focus the edge, the center will probably be somewhat out of focus. So if you focus right there, you have a good medium focus. And what I look for is the individual raster lines. I look at each individual. Don't look at objects, but look at each raster line. See if you can make those raster lines as sharp as you possibly can. You know, can you actually see them? You know, and of course, when you have an object on there, it's really easy to see the individual raster lines. On a 13-inch, it's much more difficult than on a 19 or a 25. You have the same number of raster lines, no matter how big the picture is. There's still those 250 lines. If you have a 25-inch TV, you can easily see each individual raster line. On a 13-inch TV, it's much more difficult. All right, well, let's see what other adjustments we have. Oh, on the subject of brightness and contrast, some monitors do have additional brightness and contrast controls. The brightness control, if it's not the screen control, another brightness control works on a different level. The screen control actually works by putting hundreds of volts on the electron gun assembly, on the G2, the grid 2, the screen grid. Another brightness control might be called black level. And this monitor has a brightness or a black level control. Does the same thing. But if I turn it up too high, do you see how it looks real smeared? If you crank that brightness up too high, the black level or brightness control. And it doesn't even look that bad in this case. What you'll get is the picture will smear. Let me change the pattern. See if there you go. Watch what happens. Let me turn down the brightness, or the black level as it's called in this particular monitor. Whoops, that's horizontal hold. Turn this brightness back up. Watch what happens as I exceed the proper brightness level or proper black level. Watch it start to smear. See right there? See how it smears? And it moves over to the side like this. The proper level for this is not this high. You're overdriving the video circuit here. Bring it down to the point where things look crisp, and then adjust the screen accordingly. In some monitors, the screen pot is sealed with silicon. In the new Wells Gardner monitors, the screen pot, you're not even supposed to adjust it. Although I've broken that silicon off many times because I want to adjust the damn thing. But that's sealed, and you're only supposed to adjust the brightness and the contrast with the low-level pots, the smaller pots. Basically, my suggestion to you is mess around with each control to get familiar with them and see what they do. And adjust it till you get the cleanest, clearest possible picture. If you get really confused, center every control and start from there. That's what I do anyway. Okay, there's some other adjustments as well. One is the vertical size or the vertical height adjustment. That's pretty obvious. Vertical size. Now, as you adjust the vertical size, it may start to roll, as this one did, because as you adjust the vertical size, it affects the whole vertical circuit. This is really subjective. I personally don't mind seeing a little tiny bit of black on the top and the bottom and the sides of the picture. I want to see every bit of what the computer is generating. Some people overscan a little bit. Your regular TV this is overscanned as well. You know, your regular TV here. When you watch broadcast TV, there's about this much on the edges that you probably ain't seeing. When they film stuff, when they videotape stuff, they always, in the viewfinder, they have what's called a TV safe area. They move in a little bit and they put a little viewfinder within the picture like this, because they don't want to put any important information on the edges, because most home TVs, that's going to be gone because they're overscanned. So I personally don't like to overscan, but that's totally subjective. If you like it, if you don't like to see the black, fine. Just operate it that way. Now, there's another control called vertical linearity. I don't think I'm going to be able to adjust this too much. Let's see what I can get on this. Let me first explain what vertical linearity is so that you know what you're looking for here. Am I boring you? I'm almost done, guys, then we can start having some fun, so just bear with me for just a sec. There's another control that you'll see in monitors. It's called vertical linearity, sometimes abbreviated VLIN. Here's what this means. All of the raster lines are supposed to be evenly spaced from the top to the bottom of the screen. That's when you have good vertical linearity. When you have bad vertical linearity, they may be squished at the top and then stretched out at the bottom, or vice versa. If it's excessively bad, you have a bad capacitor. But sometimes it's just an adjustment. Now, what you're looking at here, and this is very difficult to see. You may not be able to see it because this one doesn't change it very much. You'll notice that the distance here between these guys is always the same. If I adjust the linearity to make it bad, can you see how it kind of changes the spacing between them? It's really subtle. This, maybe in another monitor we'll be able to see this a little better. quite frankly, linearity adjustments in a video game is not terribly critical. But perhaps you've seen this at home TV. You ever watch home TV and you're watching and the news anchor guy looks like a cone head or something, like the top of his head's all stretched out? Or he looks like that Dick Tracy character, flat top, the top of his head's all squished like that. That's bad linearity. If it's bad enough to be noticeable, you probably have a bad capacitor. Probably. Of course, there's also vertical position. And this one, the vertical position pot's broken on this one. We probably have a bad transistor. I'm adjusting the vertical position. This is supposed to be moving up and down. So here's whoever works on this monitor. This is one of the things that we're going to want to fix. There's a potentiometer on the back here called vertical position. Supposed to move this up and down. I'm turning it now. It isn't doing a darn thing. Obviously, it's supposed to move up and down. This is a pretty common problem. There's a transistor on here that's probably bad. Oh, it's gone. The transistor's missing from the board. Okay. So we probably want to put one in there. I think a 2N4401 will probably do the job. Of course, there's the horizontal hold pot. That's pretty simple. Horizontal hold. There may be a horizontal position as well. And it might be called horizontal shift. Let's see if this one works. Sure, it works. Horizontal shift, shifting the picture left and right. And then the width control we covered. The width control, that's the coil that covers the width. In the newer Hanterex monitors and in the very newest Wells Gardner, which actually is just being released right now, the width control is now a potentiometer. Yes! Finally. Because that width coil is a hassle. It really is. Now they finally have a potentiometer to adjust the width. And I think that's about it. Vertical height, vertical hold, vertical linearity. And that's it. In some monitors, the centering control is a plug and socket, a little jumper that you use to try to adjust the width. The centering, it doesn't really work very well, but some monitors are like that. Any questions so far? Okay. Well, here's what we're going to do in the lab. First of all, as I mentioned yesterday, you're going to be working in groups of 3 or 4 people each. And I don't really care who works with who. It doesn't make any difference. I would like to avoid a whole group of dumb shits. No offense. I mean, if you're totally lost, can you hook up with somebody that's pretty hip? And the pretty hip guys, I think, are probably Ken and Andy and Howard, definitely. I don't know if I've left anybody out that's smart. I apologize. I put my foot in my mouth really good here. I guess I don't really need to record this part of it, do I? And here's what we're going to do. You're going to grab a lab somehow. In other words, this monitor we got a little bit of work to do on. There's a monitor down here. There's the monitor in SkyShark. We need to replace a capacitor in that one. I didn't point it out, but it's in your book. It's bright on one side and dark on the left. You might want to make a note on the SkyShark. It's capacitor C702. It's 10 microfarads, 100 volts, I think. If I'm not mistaken. The Vigilante has the cracked PC board on the neck. We got to fix that baby. We've got in the back, there's a monitor and some of these Electrohome chassis. There's this disc or ADI monitor right here. I've got some isolation transformers up here that we'll use when necessary. And when it comes time to injecting the video signal, I've got the pattern generator. We also have the games that we can use for the video signal. Here's what you're going to do. Just wait 1 second. First thing you're going to do is fire up the monitors, figure out what's wrong with it, turn it off. When you go to fire up a monitor, remember that you're working with a bunch of other people here. Make sure nobody's got their tongue stuck in that second anode or something before you fire it up. Say, hey, clear, everybody, I'm going to fire this up now. Okay, because it's happened to me in the class before. Some guy's got his hands in there and someone plugs it in. Whoosh! You know, so be really careful about that. Because normally you'll work by yourself, obviously. You're not working with a group of people. When you get it all fired up, you think you have the problem nailed, you can start working on it. If you need parts, come up here and I'll find the parts for you. When you need my help, call me over and I'll work with you. Just be really, really, really careful. And if you're soldering, you got soldering irons out or something, don't let the soldering iron fall on the rug. It's obviously a brand new carpet, brand new tables. Also, really careful, if you put a monitor on the table, don't freaking scratch these tables. They're brand new tables, and if, you know, if you need to, put it on top of your ECG book or something. Or there's a piece of cardboard here. You can use this piece of cardboard or something. But if you scratch these tables, I'm going to end up buying it from the guy, because obviously we have a brand new room here. It's in perfect condition. It's got to be perfect when I leave. So that's all I ask. All right, let's go.